This is Geometry Lesson 1-3. The topic is measuring segments. Our objective is to find and compare lengths of segments. So today's topic is pretty straightforward. Here we go. Our first one is postulate 1.5. Postulate 1.5 is the ruler postulate. It says every point on a line can be paired with a real number. This makes a one-to-one correspondence between the points on the line and the real numbers. The real number that corresponds to a point is called the coordinate of the point. So if you look over here at this drawing, we have coordinates A and B. It basically just says I can give this spot on the number line A. I can line up with a ruler and give it a numerical value, and I can do the same thing over here with B. And the reason why is that I can actually determine the length between them. The ruler postulate allows you to measure lengths of segments using a given unit and to find the distance between points on a number line. Consider the line to the right. Line AB. The distance between points A and B is the absolute value of the difference of their coordinates, or the absolute value of A minus B. This value is also AB, or the length of segment AB. Notice the difference between the way they wrote this value and the length of AB. This one on the right is the name. It's the name of the segment. But if you write it without the segment bar above it, you're actually talking about its measure. How long is it? So AB written as they are over here on the left, that is a numerical value, whereas AB on the right, segment AB is a name when it has the line above it. So let's figure out the lengths of some of these segments. There's a few ways to do it. It says, what is ST? And when it asks you that, it's asking you what is the length of segment ST is what they're really asking you. So you want to find point S and point T. So here's S and here's T. And what you're asking is that segment in between them. How long is it? Well, you could count the segment out and using the tick marks count it out, but I would actually recommend not doing that. Because if you notice, it's actually counting by twos in the drawing, and you might forget that if you're rushing. What I would do is actually follow the ruler postulate, which says the absolute value of the difference in their coordinates. So we start with the first point, S. It's at -4. So we're going to take -4, and the difference of that and the coordinate of the other endpoint, so the difference means subtract. And we're going to subtract the coordinate of t, which is 8. Now, we also want the absolute value of this because we're actually talking about distance, and distance is always positive. I don't say I went back -12 feet. I just say I went back 12 feet. Okay, so it's the absolute value of -4 minus 8. We work from the inside out. -4 minus 8 is -12. The absolute value of that is 12. And you're going to do the exact same thing for the next two problems. Pause it and complete those two on your own. The first question says, what is UV? And that I got to be 4. And then what is SV? Which I got to be 18. Now make sure all three of these numbers should be positive because you're taking the absolute value, which is distance, which is always positive. You can see my work corresponding down there to the right as well. Okay, so from that we have another postulate. This is the segment addition postulate. This is a big deal. Do not forget about this one. Many people do. It says if you have 3 points A, B, and C that are collinear, and B is somewhere between them, then the distance from A to B plus the distance from B to C is the distance from A to C. That should make sense. It's saying, hey, if you walk maybe in a straight line and walk forward 5 feet, and then stop. Now you started at point A, now you're at point B, but you still want to get to C, so after you take a little break, you continue walking until you get to point C. Your distance from A to B plus B to C is going to be the whole distance that you traveled. So where we use this in geometry is we do a lot of stuff with this algebraically. It's saying if EG, so they're talking about this segment, is 59 units long, what are EF and EG? Well, the segment addition postulate says, well, if you know the whole thing is 59, then the sum of the parts is the whole. So I have a part EF and a part FG. If I add those together, 8x minus 14 plus 4x plus 1, I'm going to get the whole thing. So let's start working on the left of this equation, combine our like terms. We got an 8x and a 4x. 8x plus 4x is 12x. We got negative 14 plus a positive 1, that's going to give us negative 13. We get 12x minus 13 equals 59. Order of operations says to get rid of that minus first, so we're going to add 13. Our inverse of the order of operations when we're solving an equation. 59 plus 13 is going to get us to 72. Divide both sides by 12, and we now know x. Now, I like to say that we are not in algebra class. We are, in fact, in geometry class, which means you can find x, and that's really, really helpful, but you're not done if you found x. Because if you go back and you look at the question, it says, what are EF and EG? So we know that x is 6, and EF is 8x minus 14, so we're going to take that 6 and we're going to plug it in for x. We're going to go 8 times 6 minus 14. 8 times 6 is 48. 48 minus 14 means 34. Now, if you left your work like that, I would tell you that actually that's not accurate. You want to say EF is 34, and you're going to do the same thing over there with that 4x plus 1. 4 times 6 plus 1. 4 times 6 is 24, plus 1 is 25. Now, there is a way to check your work on this. There is a way to check your work on this. In order to check your work, you can make sure that the two segments add up to be the whole segment. And if you're paying attention, you may have caught that I just made a slight mistake. The directions say EF and EG. So did we actually have to find FG? No. All we needed was EF, because we actually already knew that EG was 59, so we can just add that into our answer, even though we already knew that. It's good to state it. And you can double check, hey, do 34 plus 25, are they 59? Yes, in fact, they are. So why don't you now pause the video and do the next part. Do the same thing with this next part on your own. Notice this one does ask for JK and KL, which are both parts of the whole. Here you can see my equation all set up. I'm going to pause it and solve my equation now. You should end up with x being 9, but remember, this is geometry. We don't really actually need x as our answer. We need to know what are JK and KL, so you're going to take that 9 and plug it back in. 4 times 9 plus 6. 4 times 9 is 36, plus 6 is 42, so JK is 42. Do the same thing over here. 7 times 9 plus 15. 7 times 9 is 63. 63 plus 15 should give you 68. And there you have it.